Good day, everyone. How are you? Welcome to my class once again. Today we'll be talking about an important topic, which is not so new to you. I strongly believe that you must have heard some of the things we're going to be mentioning in the course of this lesson. And so the topic again is exploring energy transfer. When we talk about energy transfer, we want to look at the concept of energy transfer. As a new student in the year 7 level of, I believe that when we talk about energy, you must have, heard the word energy before. In fact, in our day-to-day interaction with our parents, with people around us, we have made mention of energy, we have heard the word energy. And so I'll be taking you through this topic today. Exploring energy. And here is we have our lesson objective this day. Number one, we want to recognize at the end of the lesson, you should be able to recognize what energy is and its unit. You see, every concept in physics has a unit. It's like, somebody just get into the room and ask, it's 100. The next question you're going to ask the person, 100 what? 100 what? Because you want to know the unit. Is it talking about 100 pounds? Is it talking about $100? Is it talking about 100 yen? So you want to know the value, the quantity that describes that value. So also in physics, every value, every concept, every of the quantities that we deal with in physics has a unit attached for you to understand the differences between one quantity or the other, and also to know the value of that particular unit that you are referring to. So you should be able to recognize what energy is and its unit. Then you also to describe a range of energy transfer using simple diagram to see how energy is transferred. Then number three, use a Sankey diagram as a model to represent simple energy changes. All of this we're going to delve into right away. So now we go to the main concept of the topic. Number one, we're going to look at the sun. The sun is our main source of energy as man. You see, because it is from the sun the plant is able to photosynthesize. The energy derived from the sun is what makes plant to be able to develop or to produce their food in a process known as photosynthesis. And without the food from plants, man cannot survive. So that is why we say sun is the main source of energy. Plants convert this energy by chemical process to make their own food. And, we also have our own, the use of the sun to generate electricity in our various homes through the solar panel. We've also heard of that. So you also discover that, the energy from the sun is being transferred or is being converted to electrical energy. So they become a useful energy in our homes. So now, thinking about transfer, now we'll talk about energy transfer, which is the main core of the crust of our topic this day. You see, when we talk about energy transfer, we're thinking about energy transfer. When energy is transferred, useful things happen when energy is transferred. So when a log is burned, energy is transferred by chemical reaction to the surrounding, giving us light and heat. For example, if you are in a camp meeting and there is cold everywhere, you tend to set up fire using the wood and all of those things to produce heat. So the chemical in the wood, the wood contains chemical elements, the carbon. And so the wood is burnt up, producing what is known as heat and light. To heat our environment. Now, you also have the electrical source of energy. You see, when you enter a room and everywhere is dark, you want to put, switch on the bulb. Now, what happens? You see, the transformation that happens is that the electrical energy is eventually transferred to transferred or converted to heat and light from the bulb. The light, illuminates the room. So when we talk about energy transfer, we're looking at a particular source of energy being converted to another useful form of energy that is useful to man. Look at this now. Look at the diagram. If you check the diagram, we have two things there. We have the bulb, we have the bulb there. The bulb is there. You can see the bulb. Can you see the bulb? Okay, good. You can see the bulb. Yes, you can see my note. Can you see what I wrote on the board as well? Yes, good. So now you also see the candle. You also see the candle. You know, the candle, what do we do with the candle? The candle is, to illuminate the room, to illuminate the room from the candle. So energy can be transferred, energy can be converted from one form to the other. In fact, that also establishes or support the law of conservation of energy, which we are still going to get into. So energy is then transferred from the bulb, from this bulb to the surrounding, increasing the temperature. Energy is never lost or made. It's just been transferred from one form to the other. And as a result of that, the temperature is increased. So now, we talked about energy transfer. It is useful to track the process by which the energy transfer. This can be done using a simple diagram, a simple transfer diagram. When you switch on a light bulb, you want to transfer energy from light. However, the light bulb also gets hot, the light is there, the heat is there, electrical energy is being converted to light, and the light, outside the light, heat also is generated in the course of the conversion. You see, some of these conversions, some are useful and some are not useful. And so in the course of energy transfer, energy conversion, some of the energy might be useful, some might not be too useful at that material time. So now, it depends on what you need from the energy conversion. And so there is a diagram that always shows how energy is transferred and how useful, the percentage of the useful energy and the percentage of the wasted energy. Look at this. This is known as an energy transfer diagram. You see, energy stored in the generating set, converted to electricity in the wire, then it lit up the bulb, then energy is stored in the surrounding as heat and light. This is what is known as the energy transfer diagram. This diagram is known as energy transfer diagram. Energy transfer diagram. So we have it here. This is the energy transfer diagram. Then we also have a diagram that shows, the energy transfer diagram shows how energy is converted, how energy is transferred from one form to the other. Then we have another diagram known as the Sankey diagram. Sankey diagram. The Sankey diagram is another wonderful diagram that we use in, showing the quantity of useful energy that is converted or transferred, and the the magnitude of the, wasted energy that is, transferred. So now you have this, for example, electricity. Let's assume the energy that is being generated from this bulb is about 100 joules. 100 joules. Remember, joules is the unit of electrical energy. So now, what happened? Now, 100 joules is being generated from the bulb. Now, here we have the major reason why we lit up the bulb, why the switch is powered on, is because we want the room to be illuminated. So our target, the useful energy target, is the light. So now, from this bulb, what do you see? The Sankey diagram gives you the percentage of the energy that is useful. For example, here, 75 joules was given as light, while 25 joules was given as heat. So what we need mostly from the bulb is light. So definitely 75 joules given as light to the surrounding. So 75 joules gives us the useful energy, the quantity of the useful energy that is being used here. So now, I'm going to give you assignment. You get back home. When you get back home, look at, the various forms of gadgets that you use, and be able to draw their Sankey diagram. The Sankey diagram will tell you how many percentage of the energy that is in that particular device is useful and how many is wasted. You're going to do that for your pressing iron, the electrical fan, the electrical cooker. You're going to do that for, let me write it out, what you're going to work on it as you get back home after this class, because I want to see your understanding before we continue from where we are going to stop. So now you are going to, your assignment is going to be that. But before the assignment, I want you to ask me any question from what I have discussed with you so far. Is there any question? Okay, no question. Okay, good. So since there is no question, here is your assignment. Sankey diagram for all of this. Electrical cooker, electric cooker. We are going to have for iron, pressing iron, pressing iron, for refrigerator, send for ceiling fan, then for your for ceiling fan, and you are going to also have that for your stereo. So 5, there's 5, 1, 2, 3, 4. Oh, sorry, there's 1 here. Okay, you start from here. Let me rub it off. So you start from here. 1, 2, 3, 4, 5. So you submit it in our next class. No question? We're going to round up the class here. Thank you.